Hi again and thanks for joining us. In this video, that is episode 40, we're going to pick up where we left off last session and continue our discussion about connection states in RouterOS. First, we'll briefly talk about the invalid connection state and then see how we can use connection states to manage our network's ongoing traffic. So, in our previous video, we talked about the new and established connection states. After these two, the third connection state you'll come across rather less frequently is invalid. In RouterOS, when packets cannot be identified or they do not carry any of the four other states, they'll be regarded as invalid, and therefore, it is suggested that you drop all invalid packets for the sake of network performance and security. If you refer to the Firewall and QoS menu and then the Filter submenu on MikroTik's documentation reference, you'll come across a table listing various IPv4 properties. In the row on connection states, the nature of an invalid connection has been restated as a packet that does not have a determined state in connection tracking. This is usually because of severely out-of-order packets or packets with incorrect sequencing or acknowledgement numbers, or in the event of overusage regarding the device's resources. As a small note, bear in mind that packet sequence numbering is more concerned with TCP packets, and the invalid connection state can be seen more frequently in TCP traffic. Also, note that invalid packets will not be available in network address translation, since only packets with the new connection state are used in NAT. Anyway, if you recall, we created a forward filter rule with the pass-through action on the class AP to log the ongoing traffic on our network. Now, if we refer to the trainee router and ping the address of 8888, we'll see that the very first packet of the forwarded traffic will be shown with the new connection state in the class AP's log records, which means that the connection has been registered in the class AP's connection table. Moreover, subsequent pings and ping replies between our source and destination will bear the established connection state, meaning that this connection exists in the connections table. Note that if you stop the ping and restart it before the timeout countdown of this particular connection in the class AP's connections table, you will not see the log record of the connection with the newest state in the log records. Why? Because the timeout has been reset and that connection remains registered in the connections table. A similar scenario can happen with input traffic. If we create a new filter rule with the input chain and the log action on the class AP and ping this device from a third-party device outside our home lab and on the WAN network of the class AP, we'll see that the very first packet again carries the new connection state and the rest of the incoming traffic comes in with the established state. Therefore, in its current state, the class AP is receiving and accepting traffic from both its LAN and WAN networks, and both of its interfaces are operating as in interfaces for the ongoing traffic. However, if you remember from previous sessions, the LAN network was the network which we presume to be safe, and the WAN network, given its wide and almost infinite domain, cannot be carelessly trusted. This means that for the class AP, the interface facing the trainee router and PC, namely the WLAN1 to class interface, is the in interface that can be trusted to accept traffic. As a result, in order to monitor and manage input traffic using connection states, we'll have to teach our device which traffic is safe and which type of data cannot be trusted. To do so, we'll first create a filter rule with the input chain. We can also limit the filter's protocol to ICMP for more convenience so that we only monitor ICMP ping packets in this video. We will set the action to pass through and also choose a suitable log prefix. Next, we'll create a second filter with the input chain, but this time we'll designate this rule for the WLAN1 to class in interface and bound it to packets that carry the new connection state. Finally, we'll set the action to accept so that all packets with these parameters will be accepted by the router. Remember to drag this new rule to the top of the table so that it operates first in the firewall sequence. Now, if we send input traffic by pinging the class AP from the trainee router, you can see that all log records are shown with the established connection state, and you no longer have a new state for the first relevant log row. The reason is that the very first ping packet that has the new connection state has been picked up, accepted, and sent out of the firewall process by rule number 1. Therefore, rule number 2 does not detect the very first packet and simply logs the following packets with the established state. In the next step, we'll create another rule with the input chain, but this time for the established connection state and with the same accept action. You might be wondering why we specified WLAN1 to class as the in interface of new connections, but not for the following established connections. As we mentioned both in this video and at the very beginning of our introduction to Firewall, in the world of online networks for any given device, there is the trusted inner circle, or the LAN, and the rather unknown outer circle, or the WAN. When we chose WLAN1 to class as the in interface of new connections, in effect, we determined the trusted LAN for the class AP. And since established connections follow in the footsteps of a new connection, we don't need to specify an in interface for them in the case of this input traffic coming from LAN. Bear in mind, though, that things can be different for forwarded traffic, which we'll discuss down the road. In the end, just make sure to bring that rule to the second row of the entire firewall process. Now, if we repeat our ping from R2 to the class AP, you'll see that no further log data is being recorded. And once we reset the traffic counters on our filter rules, you'll see that all the input traffic from R2 is now being processed by rules number 1 and 2, and rule number 3, that was recording the log activity, shows 0 traffic. With these actions and processes, we have used connection states to manage the incoming traffic from the local area network. The question, though, is the class AP secured? The answer is not quite. We still have the wide area network, and if we ping the class AP from another device in WAN just like before, the same process of registering a new connection and turning it into established connection will be repeated, the evidence of which are the packets and traffic being recorded by rule number 3. In this situation, for a network such as a home lab or a training workshop, which you wish to keep isolated from WAN input traffic, you can create a new rule only with the input chain and the drop action. By leaving other parameters empty, you are telling this rule to include everything else other than what has been specified in previous filter rules. In the end, you should remember to drag and drop this rule to the third row for the correct order of priority. With these settings, if you restart the ping originating from the device in the wide area network, you'll get timeout results, no further log data will be recorded, and the filter rule with the drop action will start counting all the input packets it's dropping, making sure that your device is safe from unwanted traffic from the wider internet domain. One final point to mention is that creating a drop rule in the middle of an ongoing connection such as a ping may not prove effective. For best results, we recommend that you stop ongoing connections first and then create a firewall rule with the drop action. To do so, you can either stop that ongoing connection, or if you're not sure about its origin, once you have created your drop rule, you can refer to the connections table, select all ongoing connections, and remove them from the connections table so that all outstanding connections are reset. Thank you very much for watching. Now that you understand connection states, you can use them to your advantage to manage traffic in your network. Next session, we'll take a pass at the related connection state in RouterOS. Let us know if you have any questions and stay tuned for the next video.